All right, so today what we're going to discuss is about the CCNA collaboration. As we know, there are two papers in CCNA collaboration, 21060060. This is the exam code. And for the other paper, we have 210-065. These are the two exams that we have in the collaboration. So this particular, as you see here, implementing Cisco collaboration devices, right? So this talks about the voice. So you will have here in this particular module, in this particular paper exam, you will have all together completely about the voice, the explanation of the voice, how the network is set up, how it works, what are the main components of the voice, right? As you see, they describe the characteristic of Cisco Unified Communication Solution, provisioning end users and associated devices, right? And then sub feature of the call manager as well as call manager express, configuring voice messaging and presence. So integration of call manager and Unity connection for the voicemails, and maintain Cisco Unified Communication System as in CDR and CMR reports, pulling out the reports, generating RTMT reports to monitor systems activity, and so provide end user support, where verify PSTN connectivity, define fault domains, troubleshoot endpoints issues, reset single devices, describe how to use phone applications. That's there in this first paper. In the second paper, it is more into the theory. As you see here, implementing Cisco video concepts, describe the functional components of video solutions. So describe all those one by one: media management, video convergence, media players, recording and storage, endpoint configuration, where describe video product models, describe environment recommendations, implement desktop endpoints and surveillance cameras, and describe feature and functions. And not the least, troubleshoot and support conferencing concepts. So we'll talk about anyways the video part later, but what we will be focusing today in this session is the voice part. Okay, so let's get started with the content what we have. All right, so this basically over here in first chapter 1, traditional voice versus the unified voice. So basically, if you understand from where we started the voice, what was the first stage of the voice when we started like phone, if you talk about like BSNL connection, telephone, landline connection to your home, right? How it was working before, and then how this voice, evaluated gradually, and what we are using now. So if you talk about this way, what we were using before is called, one moment, this chapter walks through the following: PSTN, public switch telephone internet network. So we'll discuss about the PSTN. PBX, private branch exchange. What is PBX and key system? We'll also discuss analog circuit and digital circuit. So as we discussed earlier days, what we were using is analog. Means this is a phone. Over this phone, when you speak out, this analog particular will get changed to electrical signal. Means this voice will get changed to electrical signal. So earlier days, what we were using voice in the form of electrical signal. What does it mean? Means whenever you speak over the phone, right? This is something we are talking about, analog connections, right? So as you see here, analog connections. See, in 1987, Thomas Edison has introduced a device known as a phonograph. We all are aware of the phonograph, what it is, right? What is phonograph? It is a device that records the voice and playback voice. This was the first device actually introduced by, Thomas Edison, phonograph, right? This device used to record sounds by pressing a needle into a cylinder recovered with tin foil. What does it mean? It means that there was a device and this particular phonograph used to record the sounds, right? As well as play back the sounds or the recording by pressing a needle. So if you remember, there is one, a big plate like this, right? And we had a kind of very big speaker like this, which is connected like this, right? And in this, we have a needle. This needle used to move around to this plate, isn't it? If you remember the phonograph, earlier days we had, we also watch sometimes in movies and all, old movies, isn't it? So why I'm discussing this? It's because this guy over here, Thomas Edison, what he says that in order to reproduce something, we need some sort of properties. The phonograph, the properties is various intention in tin foil, right? What is the property in the phonograph? The various intention in tin foil. So there, this was a plate. This plate was coated with the tin foil, right? And that is where this needle used to scratch the tin foil, and that is how the sound used to come. All right. So everywhere, in fact, in cabling world also electric current is used, and so since we know that voice gets converted to the electrical signal here, electrical current, but what about the properties? The properties are electrical voltage, frequency, current, and charge. They are the properties based on pitch and tone, how loudly you're speaking, how softly you're speaking. Based on that, this frequency, current, and charge will be adjusted, right? So everywhere there has to be some property which will be responsible to carry your data, right? So in voice, since voice gets converted to the electrical signal, right? And that electrical signal, the properties contains all those. Signaling includes messages such as dial tone, dialed digits, busy signaling. So signaling is something here. If I have to send a ringing signal, so this is also signaling information, isn't it? If I have to tell someone that this user is busy, right? This is also a signaling information. So we'll talk this signaling, this all in a moment. But let's understand first what all are the terminologies that we use normally in when we are using phones, whether it is at home or whether it is office, right? So circuit composed a pair of wires. What circuit composed? So there is a circuit called this cable. If I remind you the BSNL cable, right? A thin, very strong cable, which gets terminated to your home, to the landline phone, right? That wire, it contains two wire, the composed wire, two pair of wire. One wire is called ground or positive, right? Called tip. So if I say this way, this is wire. In this, inside of this, we have two wires, right? One is called positive, ground, positive or tape, and one is called negative, ring, right? And if we also discuss here about the how current flows, right? When positive and negative are separated, there won't be any current in this, right? When positive and negative gets connected, right, then only the current flow will happen. Do you agree? Right? So in phone word, there is something called on hook and off hook. When the phone is kept in the receiver, right, it is called on hook. And what does that on hook means? On hook means these two wires. So consider this wire is like this, these two wires, this is the actual, but state is like this. So when I keep the phone, right, this wire will become like this and both the wire will be disconnected, right? This is called on hook. On hook means when the phone is kept down, separating both the wires. So if it is separating both the wires, there won't be any current flow, there won't be any signal, right? And where this wire comes from? This wire comes from, where do you take connection from? Landline connection and all, right? So either you can call it as a central office or we can call it as a PSTN, public switched telephone network. Right? So this wire comes from the PSTN. Now this PSTN over here, the device what we use here, we'll discuss about that. But this device, what it knows that this phone is on hook, means there is no signal in this. This phone is idle, right? But when you lift the phone, what will happen? Resulting both the wire connecting, this wire will get connected to the positive end. This is positive and this is negative. Both the wire will get connected. And the moment it gets connected, PSTN will get to know, okay, this phone has gone off hook. And that is where it sends what? Dial tone. Like this. Means now you can dial the number. Right? And that is where you start dialing number. You start pressing digits 1, 2, 3, 9, 8, 1, whatever, 80. Right? So you understood what is on hook, off hook. When the phone is down, it is on hook. When phone is connected or you lift the phone, it is called off hook. In other term, when on hook is when both the wires are separate, off hook is when both the wires are connected. This particular scenario, this particular situation is also called loop start signaling. So we discussed, right, as of now, in previous slide, we discussed about the signaling information like dial tone, like busy dial, busy tone and all those, right? Because this PSTN, if someone, let's say, if someone from here calling this number, if someone from here calling this guy, and if this guy is off hook, busy talking to someone, so the PSTN will send here what? Busy tone. How they will send busy tone? They will send busy tone based on the signaling. So there are in an analog, there are two types of signaling: loop start and ground start. So this situation, what we discussed, is called loop start. Means when phone goes off hook, right? Means both the wires are connected. When it goes, when it becomes on hook, both wires are separate. This situation is called loop start signaling. We'll discuss about that over here. Right? So LSS is used in home environment. This loop start, there are two signaling, analog signaling type, loop start and ground start signaling. LSS is used in home environment and susceptible to a problem known as a glare. Okay. What is glare? So why do we use loop start in the home environment? Because consider this scenario over here. This phone at home, you have taken a connection from PSTN. This is a PSTN, and I have also one phone over here and over here, right? Consider here we are using extension 1001, anything that you can consider, 1002 here and 1003 here. Now, since we have taken the connection from where? From PSTN, right? This guy calls, or you are getting bored over here sitting idle, you want to make call to your friend, this guy. This another relative, they also thinking of calling you. Let's say their phone goes off hook, they dial number 1001. Call comes to PSTN. What PSTN detects? This phone is both the wires are separated, means this phone is idle. Means I can send what? Dial tone. I can send ringing signal, isn't it? Now PSTN will send a ringing signal over here. Now at the same moment, the moment call reaches here, you lift out the phone to dial this friend because you were thinking to make a call. Now the moment you lift out the call, what will happen? Ultimately, this call is connected, but you are not aware of that there is someone already there in the line, because your intention is to dial the number 1000, right? 3. But in line, someone is there and talking hello, hello, hello. So you will be surprised to find I haven't dialed anyone, but still somewhere someone is there in the line, right? So fortunately, this call gets connected. But think of scenario where the call has reached till here at this particular point, right? And you lift out the phone. So if your phone goes off hook, ultimately call will be dropped, isn't it? So because of this situation is called, when the call gets dropped, this situation is called glare. And because of this glare, we do not use this in business environment, because in home environment, making call or receiving call, the chances of making call or receiving calls are very less. We can still utilize that. But if you talk about business where you receive the call every time, you dial the call number every time, in this case, so many calls will be dropped, right? So what we use in the business, ground start signaling. Now, what is ground start signaling? Ground start signaling X payphone system. X payphone system means earlier days, we all have used this PCO booth phone where we have to insert the coin. But do you remember, even if your phone goes off hook, you take the handset right out off, you will still not receive any dial tone. You will receive dial tone when you are inserting the coin. So what coin does there? It does the same thing. It actually falls in particular tip wire, positive wire, and makes both the wire connected. And the moment it gets connected, PSTN gets to know that, okay, this phone has gone off. Let me send a dial tone. And then you'll start dialing numbers. That particular process is called ground. There what we use is the ground start signaling. Okay. So in analog, there are two types of signaling: loop start and ground start. Now here, two things. If you talk about the disadvantage over here, I see two major disadvantages. One, if this is a business, and if I have a 10 agents, right, I need 10 connection from the PSTN. Means one connection at a time, one call, one connection, right? So if I have 50 users, I have to take 50 connections from PSTN. So don't you think across the company, everywhere you have the cabling coming from PSTN? Everywhere cabling, right? Because one call, it supports one connection, one call. Second, since it is an electrical signal, right, which we just not discussed, voice gets converted to the electrical current, and current cannot, our current is a signal which may get weak after a certain distance. So in order to re-amplify or regenerate, what do we use? Repeaters, right? So if signal is like that, I will use repeater over here. So now signal is again like that, but repeater is what? It is a dumb device. It doesn't know what is voice, what is data. It just knows how to re-amplify, regenerate the signal. And that is how and your voice quality will be compromised. You won't have that much good voice quality because of the noise and all. So these are the two major disadvantages in the analog connection, right? Same thing over here, the evolution of digital connections, right? Disadvantages: repeater is used to regenerate the signal, resulting poor voice quality, and number of wires from central office to end users in case of large support. So now in order to resolve those two things, we moved from analog to digital, right? We moved from analog to digital. Clear? Now so how we are achieving this, both two? So first of all, digital means what you are speaking over here, over phone, right? That will get converted to 0 and 1 bits, right? Means these bits can travel up to any distance. We do not need any repeater to regenerate these bits. First resolution of this. Second, since we have a circuit type, single wire can contain multiple calls using TDM, time division multiplexing. It allows voice network to carry multiple conversations at the same time over single 4-wire path. Right? Means this TDM, what it does, if this is a PSTN, let's say, right, and I have taken the connection, I will deploy TDM over here, and these are the phones. Right? And these phones are connected to it. Now all three phones, this TDM, what it does, it allows multiple calls to carry on the same wire. Means it divides that into the different time slots. So TDM means it will divide into different time slots. Let's say time slot 0, time slot 1, time slot 0 again, and time slot 1. Let's say 2 calls. So what all conversation I'm receiving from this phone, I will keep in time slot 0. What all conversation I'm receiving from this phone, I will keep it in time slot 1. Right? So that is how the PSTN, when it receives time slot 0, it will gather all data, right, with the time slot 0 and keep it separate. Time slot 1, keep it separate, and that is how the PSTN will, separate both the calls separately using this TDM. Clear? Now, what kind of circuit we use, what kind of connection we use? So we have seen in analog, 1 wire, 1 call, but here what we use is T1 and E1. What we use, T1 and E1 lines, right? So T1 means 24 channel. T1 means 24 channel. We'll discuss this in a moment anyways, but what about a signal type of signal? Because in analog we have seen we use loop start and ground start for signaling information, but in digital we use CAS and CCS signaling type, right? CAS is channel associated signaling. Signaling information is transmitted using the same bandwidth as the voice. CCS, common channel signaling. Signaling information is transmitted using a separate dedicated signaling channel. We'll discuss one by one this. Okay, but when we are using, so let's say, as we discussed, we have two types of circuit, T1 and E1. So if we are using T1, how many circuits we'll have? T1 means 24 channels. How many channels? 24 channel. And E1 means 32 channels. Each channel can carry one voice call. Means here 24 voice calls, and here 32 voice calls. So if I am taking a connection from PSTN, right? So, and this is T1, means I can connect 24 users over here, and this circuit can carry 24 calls at the same time, right? But it depends what signaling type you are using. If you are using here CCS as a signaling, when using CCS configuration with T1 lines, right, the 24th time slot is always the signaling channel. What? 24th time slot is always used for signaling. Signaling like dial tone, busy tone, ringing signal, right? Any informational message. So means what? So if I'm using CCS over here, I am getting how many channels left for voice? 23 channel left for voice, and one channel is used for signaling. Means at a time I can use 23 channels for voice, 23 connections if I am using CCS. Similar way, if I am using E1 lines, 17th time slot is always used for the signaling, because we have seen here T1 24 and E1 32, right? So if I am using here E1, the 17th time slot is always used for the signaling, means 17th and 32. So here I will get 30 channels for voice and 2 channels for signaling. So using CCS signaling type, I will be having with the T1 23 channel and with the E1 30 channels. Right? Little bit about signaling channel. Digital voice connection PSTN T1 is used in US, Canada, and Japan. This T1 kind of T1 circuit 24 channels, 64 kbps, known as a digital DSOs, digital signals. Each channel supports single voice call. Other than these area, E1 circuit is used. Means these area, US, Canada, and Japan, we use T1. Rest we use E1. E1 allows to use up to 30 DSOs for voice calls when we are using CCS channel signal type. Right? Now this T1 circuit 24 channel means what? 24 voice calls again. Now let me show you this way. When we are using CAS signaling type with the T1, right? So T1 digital voice connection that use CAS actually steal binary bits for signaling called drop the bit signaling. T1 carries a sequence of frames, and each frame consists of 192 bits plus one frame bit, total 192, 191 plus 192. So let me tell you what calculation it does it look like. T1, it will have every call, right, will have 24 frames. Each frame will have 8 bytes information. They are called DSO, digital signaling. So one voice call, I'm talking about one voice call. One voice call, okay. How many frames it will have? 24 frames. So let's say frame 1. This notepad is not working, that is I'm a little struggling in typing this. I don't know why. Maybe if I, one second, if I do this, it makes the process. Okay, so I'll fix it this maybe later. But as of now, understand this. T1 digital voice connection, we will have frame 1 and till frame 24. So frame 24 in one voice call. Okay. So what happens in one voice call when we have 24 frames? This frame, what they carry is DSOs, digital bits 0 and 1, means 8 bits, 1 byte information. So here you will have 0 1 0 1 0 1 and all, isn't it? This is called DSO, digital signaling. This is called digital signaling. Now, what happens in the cache signaling when we are using with the T1, sixth frame, this is sixth frame, every sixth frame, and eighth bit, which is, let's say 1 1 and 2 3 4 and 8, eighth bit is used for signaling. So it drops it, mean this bits is this particular signaling cache steals it and used for this signaling, means this 8th bit will be always used for signaling when you are using CAS in T1 circuit. So since it is not consuming the whole channel for signaling, it is just robbing one bit for signaling, it will have still 24 channels for voice call. But in CCS signaling, we have seen, since it consumes one whole channel for the signaling, isn't it? And that is where if I multiply 8 multiply by 24, it will become 192 bits, right? And to carry 192 bits, how much bandwidth you should have? 64 kbps bandwidth, right? So we'll talk about something called codecs and all maybe later. So each frame consists of 192 bits plus one framing bit, total 192 bits per frame. So here we have a super frame groups 12 of these 192 bits frames together, and cache looks every 6th bit, 8th bit for signaling, known as a and B. These signaling are called as an A and B, the name. Extended super frame groups 24 of these 192 bits frames, and cache looks every 6th and from frame 8th bit from signaling, called ABCD. Right? So this is something we'll talk later. But as of now, understand, when we are using cache with the T1, we'll have 24 channels for the signaling. When we are using E1, we'll have 32 channels for signaling. But when we are using CCS, T1 will have 23 channels for signaling, and E1 30 channels for signaling. Right? ISDN is used for the video connection. So whenever we take a video connection, it is always taken from the ISDN. So we have discussed PSTN little bit. This is called PSTN, who provides you the connection, analog connection or digital connection, right? Same PSTN will be also called as an ISDN when you are getting voice or video connection from the. So what protocol they use is Q.931, right? What they use, Q.931. This is a signaling protocol used in ISDN circuit for signaling information. For signaling information. Understanding PSTN. So let's understand the PSTN also. Pieces of the PSTN. So if you see this diagram, they are called central office switch. So within PSDN, we'll have central office switches. Between two central office switches connection, this is called trunk. This is not Cisco switch or something. This could be your PBX that we'll discuss in a moment. So whenever we take a connection from PSTN, the connection between your phone and that central office, which is called local loop. This is your analog telephone. Analog telephone means one call, one connection, one call at home. If you have a business, right, then you can also take a trunk connection from PSTN, terminate in local PBX, right? And this PBX will be used to connect multiple digital phones also for your office use, right? They are the digital phones. So PSTN, sometimes we also call it as a central office or exchange office. But going back to this, analog telephone, connects directly to the PSTN, converts audio into electrical signals. Local loop, link between customer premises and telecom communication service provider. Central office, switch provides services to the devices on the local loop. Trunk provides a connection between central office switches. Private switch provides a connection, and customer does not need to take connections from central office. Digital telephone connects to PBX, converts audio into binary. Okay, understanding PBX and key systems. So earlier days, when we talk about, when we have so many phones, these phones, to manage these phones, right, there will be some sort of server. Otherwise, who will manage the phones, isn't it? So what device we used to use, or we're still using somewhere, the part of word PBX, private branch exchange, right? So most organizations choose to use PBX and key systems internally to manage in-house phones, and allows internal users to make phone calls inside the office without using any PSTN resources. So if I do not need actually to call outside, I can deploy this digital phones inside of the company, deploy PBX, connect all the phones to the PBX, and that is how you will be able to, just like connecting computers to the switches, and that is how you will start communicating. PBX looks like a huge box. So PBX, it is kind of a huge box with many cards in it. Each card has a specific function, like line cards, right? So I can compare these line cards in the switch line cards. All handset phones will be connected to the line cards, because in this line card, what we'll have is number of ports, right? So similar way, like this is kind of, consider this is a PBX box. In this, you will have ports, line card, and all phones will get connected to these line cards. Okay, trunk cards. So whenever you take the connection, let's say this is a trunk card. Whenever you take the connection, the trunk card will be connected to the PSTN. So any connection which is coming from PSTN will be terminated to the trunk card. Just now we have seen in the topology. Control or complex, or you can say the motherboard or the processor. So it has also got control complex, which will be used for call setup, routing, and management functions. And so inside of this, we'll have motherboard, which will be processing calls from one phone to another phone. The voice signaling protocol used around the world is SS7, which we'll discuss. Now, since we have discussed PBX and key system here, PBX and key system, let's see what is the difference between it. So PBX, it connects digital phones. Key system connects digital as well as analog phones, and acts like a central office switch. As we discussed, central office switch, here this switch can be a PBX also. Used in large company, 50 users and plus. So if you have more number of users, phones, in that case, you can use PBX. If you have less number of users, you can use key system. So if you want to go outside, as in if you want to call outside of the network, you have to dial 9. But in key system, if you want to dial outside, you have to press line button. Right? Now, if you're talking about the uses in nowadays, yes, it is still being used, PBX and all, for to manage the voice telephony. The reason being because there are a company who invested before, purchased PBX and all, migrating from this PBX to the new, what we are using now, we'll discuss about that in a moment. Migrating from that, it will cost to the companies. So there is the few companies, they're still using PBX in the inside of the company for the voice telephony. Talking about the PSTN numbering plan, how PSTN numbering plan looks like. This numbering plan is based on the NANP, North American numbering plan, which is called E.164 format, means the complete number. So break down into the following components. This is the whole number. In this whole number, this is called your country code 1 for US. This is called area code or state, Arizona. This is called exchange or central office code, means which exchange I have to send that call to. And this is called station ID, 4-digit station code or station ID. So when we have what? We have 1 or plus 9180 like this, right? We have plus 9180. So 91 is going to be what? India. 80 is going to be Karnataka or Bangalore, and then rest of the central code and the station code. Right? So what this is what we discussed about the digital. So we discussed analog, and we also discussed how we moved from analog to digital, isn't it? Now we also don't use digital much. What we are using is voice over IP, called VoIP. Voice over IP. So why it is a big deal for business? This voice over IP, why it is a big deal for business? It is a big deal. Why? It's because of these, some of the benefits that we are using after using VoIP. Means reduce the cost of communicating forward calls over WAN connections. What does it mean? In PSTN, you are charged per call basis, isn't it? But in VoIP, you are not charged per call basis. You are charged because you have subscribed for the bandwidth, right? So you're not charged per call basis, but per, bandwidth basis, monthly basis. Reduced cost of cabling. I don't have to purchase T1 and E1 circuit. What cabling we are using for data, the same cabling can be used. Seamless voice network. Using dial plan, all users can dial each other using 4 digits, right? So in digital, we still have to dial complete 10 digits to reach the destination. But here in VoIP, we can only dial 4 digits, and using 4 digits itself, we can reach another branch office or so between two communication. Take phone with you anywhere, plug and play. So you can disconnect here, connect in another place, and then it will be used. So it is for plug and play. We can also use here soft phones, but in digital or analog, we cannot use soft phones. Means if you are traveling to abroad or somewhere for the meeting, you don't have to carry your hard phone. Since you have soft phones installed in your computer laptop, you can use that soft phone. Unified email, voicemail also integration, so we can, apart from the phones, we can also, you know, make a call from our email. We can also take voicemail from to our laptop directly. Increased productivity, voice extension can forward to ring multiple devices. So if I want to ring multiple phones, it is possible here. Maybe if in case of agent, in case of customer call center, customer care and all, I want to ring multiple phones. Feature rich communication, voice, data, video have combined, and due to the caller ID information can call. Voice, data and video have combined means, earlier you used to take, earlier days, this is a router. For video, you have to take a connection from ISDN. I'm talking about earlier days, right? For voice connection, you have to take connection from PSTN. And for data traffic, you have to take connection from ISP, WAN. But now all three combine together and called WAN, means all voice, video, data can be transmitted through WAN itself using IP. So because everyone uses here internet protocol IP, either version 4 or 5, 6. Open compatible, all vendors can communicate to each other, right? All vendors can communicate to each other, so that's also advantage. That is why this WIPE is a big deal for the businesses. Clear? A little bit about what we have discussed about the digital, the process of converting voice to packet, means 0 and 1. So there is one more scientist called Dr. Harry Nyquist, and other created a process that allows equipment to convert analog signal to digital, 0 and 1. Few facts about human hearing capacity and speaking capacity. Human ear is able to hear from frequency from 20 to 20,000 hertz, right? One moment. Few facts. This is the maximum hearing capacity. Human ear is able to hear frequency from this to this. Means if you receive more than that, you will become dumb. You won't be able to listen anything, hear anything. Human speech, maximum what we can speak up between this 9,000 hertz. Apart from that, what all sound comes, it is machinery sound. Telephone channels transmit frequency from 300 to 3400. But frankly saying, this 3400 is not enough actually to understand what we are saying end-to-end communication. That is why Harry Nyquist, what he said, theorem, is able to reproduce the frequency from 300, 4000. What he says, this, that if it can accurately reproduce an audio signal by sampling at twice the highest frequency. Highest frequency is, this is your plus and minus, right? This is your plus, this is minus, and this is frequency, isn't it? So what Harry Nyquist says, if we double the frequency of this plus, right, twice the sample, so this is the Harry Nyquist, if I twice it, it will become 8,000 hertz, which will be sufficient to understand the voice quality with the proper voice quality. But what is sample? Here, signal by sampling it twice. Sample, what is sample? Sampling is a numeric value that consumes single byte of information. 1 byte, 1 sample. So if I speak, right, God, right, so it will, one word will consume 8 bytes, one sample. And the process of converting analog wave into digital numeric value is known as a quantization. Clear? Audio codec bandwidth and MOS value. Now, since we are talking about voice, we have moved from analog to digital, digital to wipe. Now we are completely talking about wipe. What does that codec means here? Codec means coding and decoding, isn't it? Converting analog to digital and digital to analog. What you are seeing in the screen is called what? It is analog, right? When this particular data is converted to bits and goes through the wire, but there has to be somewhere someone who would be converting that, isn't it? Analog to digital. That is where this codec plays an important role. So these are the overall codecs in voice: 0.711, ILBC, 0.729, 726, 729A, 728, right? This is very, very popular, which we use, and this is very popular. This means, and this is bandwidth consumed, and this is MOS, mean opinion score. This tells you the voice quality, what would be the voice quality. So the lowest MOS will have highest voice quality, right? But here 4.1 is the very good quality. So if I am using G.711 as a codec in our voice telephony network, it will consume 64 kbps to complete one voice call. Means it has to be 64 kbps bandwidth has to be there, then only it will be able to set up call. Otherwise, no. So minimum requirement 64 kbps, and the score is 4.1, which is fair enough. Internet low bit codec, ILBC, the bandwidth has been reduced here. It needs 15.2 kbps to set up a call, and MOS is same. G.729, it only needs 8 kbps to set up a call. For one call, 8 kbps required bandwidth. And MOS is also very good, 3.92, right? So this most of the time we use in the LAN, local area network. Which codec? G.711. And G.729 we use normally in WAN. I'm very sorry for this bad handwriting here. Right, which consumes 8 kbps bandwidth. Rest we do not use. G.726, G.728 hardly we use, but as I told you, 90%, 99% what you will see G.711 being used in LAN, G.729 being used in WAN. Right? You will have a preference whether you want, if you want to change it, you can change it. But this is what customers favorite. This is what people's favorite. Right? So you understood what is codec, audio codec. Role of digital signaling processor. Since you are sending, you are terminating this connection where, let's say this is a router and this is PSTN and this is WAN, isn't it? So we represent router this way, and here we have all phones connected, right? So DSP plays an important role. These phones over here, they can communicate to each other without any issue. Okay, a very bad diagram. But if you want to send that call, so as of now this router is known for handling the data traffic, but now when you are implementing voice also, This router will also carry what? Also transfer voice traffic. So in order to transfer voice traffic, this router will only be able to transfer voice traffic when it has digital signaling processor, DSP. What is DSP? It is a chip inbuilt in a motherboard or separate module used to increase the capability of router, because router, as I told you, it is only capable of, it is only meant to handle data traffic, but now you are also adding voice traffic. In order to handle the voice traffic, there is a separate processor called DSP. In order to handle voice traffic, there is a separate processor called DSP, digital signaling processor. Okay. Now these DSP comes in the form of PVDM. Cisco bundle these chip into packet wise DSP module called PVDM. Packet wise DSP module means it is just like a RAM, right? And in this RAM, what we will have is DSP chips. So it depends how many DSP chips you have. So when we talk about PVDM, there are 3 generations of the PVDM, generation 1, generation 2, and generation 3. This is PVDM generation 2. PVDM 2 means the PVDM generation 2. As you see, 16, PVDM 16, this is the name of the PVDM, means it will have 1 chip in the RAM. RAM is kind of a plate, just like a RAM only. PVDM, which means it can support 16 concurrent call from here. PVDM 32, there will be 2 DSP chip inside of that PVDM 32. It can support 32 calls. PVDM 48, 3 DSP chips. 64, 4 DSP chips. And PVDM 80, 5 DSP chip, means it can support up to 5. So in this PVDM, you will have 5 DSP chips. So you have seen router, right? Router, it is inside of the chassis, you have motherboard. In that motherboard, you have to plug that PVDM. But yes, this is very important resource, or this we call as a media resource. If it is not available, router will not forward any call to outside. Inside it will work, or outside it won't work. So PVDM is again necessary, right? So what is DSP? This and a separate processor which we install in the router to process voice traffic. Clear? Last slide of today's understanding RTP and RTCP. So RTP, okay, let me make this way. Phone, one phone, another phone. Luckily this time phone, at least diagram is good. Connected to the switch. They are switch, okay. And then router. And these phones are connected to this. And also I have also called, let's say, a call processing server. Either it could be CME or CUCM, call manager, let's say. We'll talk about call manager of this, but what we are understanding RTP here. So what RTP is, RTP operates a transport layer of the OSI model. Okay, RTP adds timestamp and sequencing. It works under UDP. UDP provides port number and header checksum, which ensures that the header checksum does not corrupt it. So RTP works at the transport layer, layer 4 under UDP. What it does, it adds the timestamp and sequencing. Now what is RTP? Real-time protocol. It is a session. Whenever these two phones start talking to each other, your voice will always go over the UDP. because we know TCP in our transport layer 2 protocols, TCP and UDP. TCP is always used for data and UDP is always used for voice and video. Why? Because in TCP we have some three-way handshake which will create the session, maintain the session, and every time acknowledgement. But in voice we do not need acknowledgement, just to make this process more faster, right? In TCP we have retransmission. If packet is lost, we will request to retransmit the data. But in voice, once it is lost, it is lost. There is no point of retransmitting, right? So that is why we use here UDP. And under UDP, what we use RTP session. Means what all voice audio you are transmitting, they both phone will create RTP session. And over this RTP session, all voice digital 0 and 1 will be forwarded. Obviously, physical media is this, but over RTP session, real-time protocol. So once two devices attempt to establish an audio session, RTP engages and chooses a random even port number, odd and even UDP port number, range from 16,038,384 to 32,767. Even number means 16,384, 386, 388, like this, right? And this is RTP stream are on one way, means for transmitting there will be one session, for receiving there will be one session. So if these two phones are talking to each other, there will be two sessions, two RTP sessions. If the devices establish dual RTP streams, one in each direction, in incoming and outgoing, the audio streams stays online on the initial chosen port of the duration. So what port number has been chosen here, that port number will remain reserved till the time this RTP's session is active. But in this time, once you start talking, if this call manager is down, this RTP session is still be active. You can talk, your conversation will continue without any disruption. Yes, you won't be able to add or use any additional feature like call on hold, transfer, or something like that, because for that you need this call manager server, right? So between two phones, whenever they communicate, there will be RTP session created between two phones, and over RTP session they will transmit audio signals. RTCP is the extension of RTCP, real-time compressed protocol, which encrypts the data and then sends. Right? It is just like RTP only, but encrypts the data and sends, and it uses the odd number. It uses the odd number port for the same range, and that's something called RTP and RTCP. So now we are getting familiar of this, small things. What is codec? What is RTP, RTCP? What is DSP, right? And what is WIPE? What we discussed. What is analog? What all the signaling type in analog we discussed. What is digital? How it is overcoming the disadvantages of analog. What are the signaling types there? And then finally we are discussing now about the WIPE. We'll continue this tomorrow. That's it from my side today.